Thank you everyone. Uh, Today I discuss about the chemical properties of ammonia. First of all, when ammonia gas comes in contact with HCl vapor, white dense fumes containing the solid particles of ammonium chloride is formed. NH3 plus HCl gives to NH4Cl. Here the ammonia, it is the gas, HCl, it is in the form of vapor. So these two gases when react, then it forms a solid substance NH4Cl, and its color is white. That is why the color of fumes is white, and it is the densed, and this fume also contain the ammonia gas and HCl gas. Now this reaction is the example of reaction between two gases produces a solid substance, because these two are the gases, they produce a solid substance ammonia gas. Also, this reaction proves that ammonia is a basic substance, because HCl, it is the acidic substance. Ammonia reacts with acidic substance and form a salt. So ammonia is a basic substance, because basic substance can react with acid. Now the second, that means second reaction, ammonia is a reducing agent. It reduces the other substance. For example, when ammonia gas is passed over the hot cupric oxide, this color is black, then ammonia reduces this cupric oxide in metallic copper, and ammonia itself oxidized in nitrogen. Here cupric oxide plus ammonia gives to N2 plus Cu plus H2O. The copper is produced from cupric oxide, and for that this oxygen is removed. The removal of oxygen is known as the reduction. Now for ammonia, from ammonia nitrogen is produced, and due to that hydrogen is removed from ammonia to produce nitrogen. The removal of hydrogen, it is known as oxidation. So ammonia gas itself oxidized into nitrogen, and cupric oxide is reduced into copper, and ammonia gas helps cupric oxide for its reduction, and that is why ammonia is a reducing agent. Here in this reaction nitrogen is produced, and it helps to prove ammonia gas has nitrogen. The formation of nitrogen is in this reaction proves that the presence of nitrogen in ammonia. Now ammonia gas does not burn in air, but it can burn in pure oxygen. That means when ammonia burns in pure oxygen, then it burns with greenish yellow flame and produce nitrogen and water vapor. NH3 plus 3O2 gives to H2O plus nitrogen. Here nitrogen is produced. So this reaction also helps us to prove that ammonia contains nitrogen. Now, when this ammonia reacts with oxygen in presence of catalyst platinum. In presence of platinum catalyst, ammonia is oxidized to nitric oxide, and here the temperature must be maintained at 750 degree centigrade to 900 degree centigrade. And the ammonia, when reacts with oxygen, oxidized ammonia into nitric oxide, and with nitric oxide water vapor is formed. Now the reaction of ammonia with metal and non-metal. That means ammonia gas can react with metal and also can react with non-metal. First of all, reaction with metal. Ammonia gas can react with sodium, but it reacts with sodium in molten state, and must be temperature is maintained by 300 degree centigrade. That means when dry ammonia gas is passed over molten sodium at about of 300 degree centigrade, then the salt sodamide NaNH2 is formed along with hydrogen. Here the sodium and the ammonia, when they react to each other, then it forms a sodamide NaNH2 plus H2. Here also these reactions helps us to prove ammonia gas has hydrogen. This reaction proves that ammonia has hydrogen. Now the reaction of ammonia gas with chlorine, that means non-metal. Here there are two conditions there. First condition is ammonia reacts with chlorine, but here the ammonia is excess. The second condition, there the chlorine will be excess. Now the first one, when excess amount of ammonia reacts with chlorine, then what will be product? The product will be nitrogen and ammonium chloride. The ammonia, when react with chlorine, then it forms nitrogen gas and ammonium chloride. If you balance it, then you already see that here the ammonia is the excess in amount, then the chlorine. Now the second, when excess amount of chlorine reacts with ammonia, here the chlorine is excess, then hydrogen chloride and nitrogen trichloride is formed. This is ammonia plus chlorine gives to HCl plus NCl3, that means nitrogen trichloride. If you balance it, already it shows that ammonia is less than the chlorine. Here this compound, nitrogen tetrachloride, these two are the negative element. The two negative element forms a compound nitrogen tetrachloride. Now the very important question, it is the what is Nessler reagent? Nessler reagent, the compound here, the K2HgI2. The name of this compound is potassium tetraiodomercurate. Potassium tetraiodomercurate. This is a compound. The alkaline solution of this potassium tetraiodomercurate is known as Nessler reagent. Alkaline solution, that means the solution is made with the help of any alkali. Say it may be sodium hydroxide or potassium hydroxide. Now how this Nessler reagent helps us to detect ammonia gas. Here, when ammonia gas is passed through this Nessler reagent, a brown precipitate of this compound Ag bond O bond Ag dot NH2 is formed. Here the brown precipitate is formed. This brown precipitate helps us to detect the gas is ammonia. Only ammonia gas can form the brown precipitate when it passed through the Nessler reagent, and this produced compound, that means Ag bond O bond Ag dot NH2 is known as the iodide of Miller's base. Now ammonia is a very important reagent to detect the metallic ion present in the compound. When ammonium solution, that means ammonium hydroxide, is passed through the metallic salt, then it forms a precipitation of respective metallic hydroxide, and color of this precipitations helps us to recognize the metallic ion. For example, what happens when aqueous solution of ammonium solution, that means ammonium hydroxide, is added with ferric chloride solution. These are ferric chloride solution. When ammonium hydroxide is slowly added with ferric chloride solution, then we get a reddish brown gelatinous precipitate of ferric hydroxide, and this precipitation, that means color of the precipitation reddish brown and the gelatinous form, helps us to detect this metallic ion is ferric ion. So the color of the precipitate helps us to identify the metallic ion, and it is the ferric ion. Now another example of it, what happens when aqueous ammonium solution, that means ammonium hydroxide, is passed through aluminium sulfate solution. Aluminium sulfate solution, the ammonium solution is added, that means ammonium hydroxide is added. The ammonium hydroxide is added with aluminium sulfate solution. What happens? Then you get a white gelatinous precipitation of aluminium hydroxide. This is the aluminium hydroxide, and we get a white precipitation along with ammonium sulfate. This white gelatinous precipitation helps us to recognize it is the aluminium ion, aluminium Al plus 3 ion. That means the color of this precipitate helps us to identify the metallic ion. This metallic precipitation, that means here the FeOH whole 3 or here the AlOH whole 3, both do not dissolve in excess amount of ammonium hydroxide. These are the chemical reaction of or chemical properties of ammonia gas. Thank you.